Hello students, welcome to the video lectures of software engineering. So today we are going to talk about requirements engineering. So we are going to, have a very important and foundation kind of, step in our building any kind of software project today. So it's your requirement engineering. Okay. So what, you might be thinking, so what is this about and what's the greatness in understanding this today and why it's being said as a foundation for building any kind of software project? Because let us try to understand this with a very simple example. So let us say that you are imagine like you are building a house, and for building a house, even before you try to lay the very first brick, you should talk to the person who wants the house regarding how many rooms do they want, what kind of design they are thinking, and particularly what's their budget, and where will the kitchen goes or the doors or the windows and whatever. See, so now whatever the things that I told you are the requirements of the person who wants the house, right? So that's the reason we need to understand clearly the requirements of the person who needs the product, right? So, before we start designing or coding for our software project, so we should clearly understand what the customer actually needs, and we should not go for any kind of guess work or any kind of assumptions such. Okay. So where now this requirement engineering is all about, trying to gather, study and finalize all those needs and expectations of the customer. So basically, this is termed to be a bridge to design and construction. So now you can see it allows a software team to examine about context, about specific needs, about the priorities, about the information, functions, and behaviors. So that is the reason it is titled to be the bridge to design and construction, right? So it's because, just imagine when I say the word bridge. So on one side, we have the ideas and the needs of the customer. And on the other side, we have the technical work like designing or building the system. Right. So that is the reason why requirement engineering is termed to be a bridge between the design and construction. And it also helps us to cross this bridge very safely. And it ensures that we build exactly whatever the customer asks us for or whatever the customer is expecting. Right. So now, what exactly does this require we actually do in requirement engineering? Okay, so now we'll try to understand. So these are the requirement engineering tasks. Starts from inception, elicitation, elaboration, negotiation, specification, validation, and requirement engineering. Okay, so we'll try to see one by one what are these. Okay. So first, we initiate the requirement engineering process by identifying the stakeholders, that is the people who benefit from the system, and we try to also identify from multiple viewpoints, that is different roles, uh, you know to understand basically the different needs, and by collaborating or cooperating among the users and developers, and also asking the right questions like who the exactly the users are, what are the main goals, and the what problems will the product is going to solve. Okay, all these things are understood. This is done in your inception phase. Okay. So first we talk about this inception phase. So in inception phase, now we try to understand who are the exactly the stakeholders and what problems are we solving. Okay, and what exactly the goals are. So to better understand the inception phase, we try to talk an example. Let us assume a food delivery application. So during its inception phase, we try to talk or we try to understand that the goals of this particular application would be to connect the local restaurants with the customers, and also to provide the real-time tracking of the food delivery, and also what sort of offers that we can provide in the app, right? So that is about your inception phase. Next, we talk about elicitation phase. So what is elicitation? So elicitation is nothing but it's the process of gathering the requirements from the stakeholders. So and it is not just gathering the requirements. That means what exactly they needed. I mean, it's not just what they want or what they are asking for, but rather we also should discover the actual needs of the system. For example, just now we had a discussion of food delivery application. So you just try to interview the restaurant owners, wherein they asked you for a dashboard to manage the orders, and the delivery agents are asking for a route optimization, and the customers want to rate the restaurants. Okay, so these kind of diverse needs exist when you try to go deeper into the system and discover the actual needs. So the techniques what you can implement in elicitation can be the interviews or the questionnaires or some kind of joint application development sessions or any. Okay, so that your elicitation phase will ensure that it tries to capture these kind of diverse needs. So next we talk about elaboration, right? So let me go through the slide as well. So this is inception. It's about understanding the problem domain and identifying the key stakeholders. Next is elicitation. So then it's elaboration. Okay. So in elaboration, so it involves expanding and refining the gathered requirements. Okay. Expanding and refining the gathered requirements. In our earlier phases, we collected the requirements. That is, we gathered the requirements, right? So that is it. And building the use cases, identifying classes and relationships, creating models. Models are nothing but UML diagrams. So if suppose let us take an example, uh, if the customer places an order and just we try to break down into like the customer, the basic requirement is the customer want to place an order. So customer browses the menu, and after browsing the menu, they add the items to the cart and they just go for the payment option and they confirm the delivery address and places the order, right? So then using some use case diagram or activity diagram, we try to depict the same using the model. Okay. Next is negotiation. The negotiation is the stakeholders often have conflicting requirements. That is, the negotiation helps resolve this by finding compromises or prioritizing the features. So, for let us say, for example, if a customer, is asking for, or the customer wants a 24/7 service, but the restaurants say that they can only deliver in between 10 a.m. to 10 p.m. So during the negotiation, what happens? See, the restaurants will be accepting the orders anytime, but the delivery can happen only within the restaurant hours, right? So, I mean, negotiations happen between the uh, customer as well as the application. In our previous video lecture also we talked about the negotiation concept by relating to some features. So the customer is asking for uh, a particular feature, but we agree with that we can provide only the basic version of it, and the improvised version can be given in a couple of weeks, right? I mean, the negotiation happens in this way. So then it's about specification. So what is specification? Specification is the process of formally documenting the requirements. The output is often a software requirement specification, that is SRS. So basically, you find these elements in software requirement specification, that is functional and non-functional. Functional says that what the system should do. So that is, let us say, the system shall allow the users to make some payments using various payment gateways, that is credit card, debit card, digital wallets, or anything that falls under the digital wallet. Okay. And wherein the non-functional requirement says the performance, reliability, usability, which is nothing but non-functional. The system we shall say that the system will respond to the user within a couple of seconds or minutes, right? That is non-functional. Then it's about validation. So what is validation? So validation checks whether the documented requirements match the stakeholder expectations. It ensures we build the right system. So the techniques to ensure this is ensure or the validate this, that stakeholder expectations we are meeting or not is to conduct some reviews or walkthroughs, prototyping or test case generation. So, for example, you show a prototype of the food ordering. Just now we had a discussion. Food ordering to your stakeholders. Like you designed an application of the food ordering system, and you are just showing the screen to your stakeholders. They just by viewing it, let us assume that they point out something like there is no option to customize a dish, right? So generally we prefer to customize our dishes, right? So they found the stakeholders found and they were asking you to provide an option to customize the dish. Like when you order some pizza, you try to ask for extra cheese on it or some kind of toppings on it, and so in such a way. So you just try to capture this feedback and update the requirements. That is how this validation works. Okay. So next is building an analysis. Okay, model. So what is building the analysis model? Okay, so we'll try to understand this. So the goal of building an analysis model is to create a clear blueprint of the system's requirements before dividing it into design or development. So this model serves as a bridge between the requirement phase and the design phase. So in this, you'll have four things, that is scenario based elements, class based elements, behavior elements, flow oriented elements. So we'll see what are those. Scenario based elements are it which focuses on user interactions. So it captures what the users want to achieve and how the system should respond. So use case diagram is the example or the way how we show this scenario. Next is class based. So this will define the static structure of the system. So identify key entities which we call as classes, their attributes, operations, and relationships using a class diagram. So class diagram consists of your name of the class, attributes, and methods. Next is behavior. So shows how the system behaves over time, particularly how it responds to events and how different systems states transitions based on actions. So state transition diagram is the example, and also the sequence diagrams, which shows interactions over time. Next is flow oriented. So this will describe how data moves through the system, okay, and how it is transformed and how different processes interact. So that is by using your data flow diagrams and control flow diagrams. Okay. Thank you, students. Hope you all understood.